Hello and welcome back to Codeblaze. So it's been a while since I last uploaded a video regarding voxels, and this one is pretty long due. That's adding texturing support to our greedy meshing, and this would work with our knife meshing also. So as far as matching cubes is concerned, that implementation is a bit more complicated on the shader side, and I'm not that well versed with it. So bear with me, that will take some time as I figure it out. But today we'll be focusing on adding textures to our greedy meshing. And later on in this video, as usual, we'll be going over some GitHub suggestions and issues. And at the end, we'll be having a discussion regarding what would be the correct way to handle our meshes in a proper voxel system, and how could you optimize it and take more control over your mesh buffers, basically. So let's get started. So I'm going to tell you a story about how I went about deciding which approach to use for texturing. So this is around the time, well, during my second implementation of a voxel engine in Unity. At the time, I only knew one solution for texturing, that was using texture atlases, and I pretty much thought Minecraft and other such games also use texture atlasing. And it's pretty simple also, right? You have one big texture with all your block textures, and you just extract the piece and apply it to the whatever mesh you're creating. Now, texture atlasing works very well with knife meshing because all your faces are of the same size, right? It's everything is a square, so you can easily take, like, assign the correct UVs to each square, and you can extract that texture from the atlas and apply it, and it works pretty well. But the problem is when you start going into greedy meshing, right? So in greedy meshing, I think if I change this to wireframe, so our faces are of irregular sizes. Some are squares, some are rectangles, and they need not be of the same units also, right? So 3 by 3 squares are there, and then 3 by 4 square rectangles, so on. So that makes it really difficult to implement texture atlasing. But texture atlasing can still be done, but it would be very complicated. So you'll have to have two UV channels, one which will denote the actual texture coordinates in your texture atlas, and that one UV channel would denote the scale. So you will take out the texture atlas and then scale it. But the problem then comes is you'll have to do the repeating of the texture atlas over the area yourself, and it just makes the shader a bit more complicated. But there's a pretty simple approach to texturing, or you could consider it as an alternative to texture atlases. And in most of the cases, it would be better. That's using a texture array. So what texture atlas does is it packs all your texture in one texture file, and you can then index it, or you can basically query the texture atlas, right? In case of a texture array, you basically get an array of textures, and then you can use an array index to get whatever you want. So if I want to place a grass texture, and suppose the texture in the texture array, the grass texture is at index 3, I can just pass the three-dimensional UV channel XYZ, and Z would be used as the index to query the texture array. And texture array is a concept that's pretty prevalent in graphics programming, I think. You'll find it everywhere in Unity, Unreal Engine, and even in OpenGL. So texture array works really nicely with your greedy meshing, you'll see. With so less effort, we'll be able to implement or add textures to our meshes. So now enough of the theory part, let's get started with the implementation. Okay. So if you see the materials folder for the project, I have created a new folder called textures. And in this, I have imported a few textures for like the dirt blocks, grass blocks, and the stone blocks. And these textures come from the Kenny's voxel pack. I mean, you can use your own textures also, but I think this is a great pack to get started. So I'll leave a link down below, and do check it out. There are a lot more great assets by Kenny. I think everybody knows him by now. So we'll be using this texture pack, and we're not using all the textures. I mean, you can go ahead and set up all of them, but for demonstration purposes, these four are fine. Okay, so now that we have a textures, how do we go about creating a texture array? So that basically we'll need to pass that texture array to the material. Now, in Unreal Engine, it's pretty simple. There's actually an asset type for texture arrays. If you go here, you'll see a texture 2D array. You can just select this. We'll just call it Voxel texture array. And once you open this, you can basically add your textures here in the source 2D. So you see we have a source textures array here. So we need 4 elements here. Okay, and we'll select our textures accordingly. So dirt and stone. Okay. Now this indexes also matter. So as we'll be populating our vertex buffers and we'll be populating our UV channels, we'll be setting up these indexes also in our buffers. So depending upon the block type and the normal direction, we'll either set the index to 0, 1, 2, or 3. So now that we have a texture array set up, let's do the code side changes and then we'll look at the material setup required. Now, before we start with the implementation, there's actually a issue in our current implementation for greedy meshing, and that is regarding UVs. So till now, it wasn't prevalent since we were not doing any texturing or anything. But if we take the current UV setup and apply the textures, some of those textures will be rotated. Okay, and there have been GitHub issues regarding them. Okay, 2 people pointed it out, and if you actually look at the code, it's pretty understandable why this happens. And that is because our triangle's order isn't fixed. It depends on the normals. So if our triangle order changes, that's basically the way in which the face is going to be rendered, or the vertex connections will change, right? So the order of the face is changing basically. So in that case, our UV order should also change. So that's why there are cases in which the textures appeared flipped, and we'll be fixing that going ahead, because considering the normal and the axis along which the current face is being generated, we need to set the different UVs. But mind now, the fix I'll be providing right now is kind of a small fix only, because I believe there would be a better way to handle this situation, right? Like for triangles, without if else, we were able to generate the correct triangle order by just adding and subtracting the normal value. But all we need to do now is just let it get it working, and maybe we'll refactor it further down the road to make it more sensible and readable. Okay, so onwards to our implementation, I'll go to our header class, greedy chunk, and we'll be adding a new method here that will decide what would be the texture index for the current face being generated. Okay, so let's call it int get texture index, and this would take in a block. So what is the current block that's being worked upon, and it will also take the normal. So with this we'll be able to see along which direction the face is being generated, because for the glass block, the top face has a different texture and the side faces have a different texture, and also the bottom face would have a different texture, right? But so we need the normal value here, and if in your engine you need some other values also, just have a utility method that you'll be able to generate the correct texture index. Okay, we'll take an f vector here, that would be the normal. Okay, this will be a const method, so let's go ahead and create the implementation. The deep point generate definition. Okay, so it will be a simple switch case, nothing much. But before going ahead, let's talk about how we would be passing this texture index to our material. So right now we are using the procedural mesh component. So we are pretty much bound to the mesh buffers defined in that component. We can't create our own buffers or change the layout and size of those buffers. So we would have to repurpose few things here. So like we can repurpose the color channel, right? We can use the alpha value to set the index, and we can also pass in the UVs here using the other channels, or we can use the UV0 and use the first channel of UV1 to pass the index. So you have limited possibilities here, right? You need to repurpose one of these channels to pass whatever you want. So for now, I'll be going with the color alpha, since in future, if we do implementation regarding ambient occlusion, we'll be needing the color channel for something else. So let's get started with that. Let's start by implementing the get texture. And this is going to be a simple switch case only. And if you have a lot of blocks, certainly the switch case would grow. And I don't see a way around that unless you configure it in some way, but I think it's fair, like it's just a one-time setup required. So we'll create this block here, and next we'll add the empty cases also. Just generated that case. That's pretty weird. Should then generate the other cases also, but I'll just copy it out then. Okay, and we'll have one more case here. So if normal equals the down vector, in that case we'll return the dirt block only. So f vector down vector, so we'll return 2. So this indexes here are basically the same as what we have in our texture array. So 0 is the top grass texture, 1 is the side grass texture, 2 is the dirt texture, and 3 is the stone texture. And in default case, we can return 255. And the reason we are returning 255 is because the channel we are using it, right? So F colors alpha channel we are using, and each of this component is a byte. So unsigned byte basically. So we can have 255 values in here. Now you could say that that's a limiting thing, that you can only have 255 different textures, and you'd be absolutely correct. So other ways to do this would be to use the any of the UE channels to pass this, or something is to use a custom mesh component itself that we'll be discussing later on at the end of this video. So for now, let's just focus on the implementation of this. Right. So now that we have our method to get the texture index, let's pass it using our color channel. So we'll set all of these to 0 and just call get texture index here. Get texture. Okay. And to this, we'll need to pass the block that is available as part of the mask and the normal that we have computed right here. Okay. Now that our texture index is going inside the material, we need to set up the correct values for our UV. Okay. So as I said below, this would be kind of a workaround fix. I'll just copy paste it here. So depending upon our normal value, like if the normal is across x-axis, the UV order is this. Otherwise, it's using the existing UV order. Okay. So ideally, across each of the axes, the UV order would be different, but it's only the x-axis that really matters toward z-axis. Whatever's this order, right? This order fits right for the z-axis, and for the y-axis, it doesn't really matter, right? Since y is the top view, so and if it even if it's rotated, it doesn't matter. But if you're going for a perfect scenario, right? Depending upon the normal axis, you'll have to put a different UV order. Okay. So this code right here is fine. And actually that's all you need to implement texture arrays from the coding point of view. Next, we'll implement the material that will consume this data and apply the correct texture. So let's go ahead and create a new material here. We'll just call it texture array. And we'll open it up. And we basically need few things here, and we can copy some parameters from the previous material, the vertex color, as we'll basically be reusing those. Okay, so these parameters, the metallic can go in the metallic, circularity, and the roughness. Okay, next we'll also need the vertex color here, so we'll get that. And we'll need another parameter for our vertex or texture array. That comes under parameters, and here you'll have a texture sample parameter 2D array. Okay, and we can just name it texture array. Okay, so we can go in our parameter and set the default value for this, and this would be the voxel texture 2D array. Okay, now to sample this, we need a three-dimensional UV coordinate here, and we can just pass in the base color here. So it says here also, right? The 2D sample array needs a UVW input. So basically a three-dimensional texture coordinate. So we'll go here and create the texture coordinate node, text coord 0, right? And to this, we'll need to append the alpha value. Okay. Now, again, back to our code. One thing I didn't mention is in our texture coordinates, we are passing the height and width. So this height and width will allow us to repeat the texture across the face, right? So that the texture doesn't appear stretched. Okay, back in here. And so we'll take the alpha channel, and another thing to note here is the vertex color here is normalized. So it won't be between 0 and the max byte value. It will be between 0 and 1. So what we'll need to do here is multiply this. Okay, and we'll multiply this by a constant. And let's put the value to 55. Okay. Next, we'll round this off just so that, so because we want an integer as our index, right? So we'll round it off, and we'll take this texture coordinate and append to it, okay, this value, and we'll pass this in the UVW. So this append will transform this two-dimensional texture coordinate to a three-dimensional value. And you'll start seeing here that we are seeing something, right? We are seeing the stone texture here. So that's all that's required for the material setup, right? We can now just save this and apply it to our 3D meshing blueprint and see how it looks. So with this save, we'll create a material instance also so that we can modify our properties without actually needing to recompile. Okay, so the flat material instance we have created. So you see all our properties are visible here. And we'll go to our main world and we'll change the material to texture array flat. Now, if I play the game, it should hopefully work. Otherwise, we'll see if there are any issues. Okay, so it's working. And we just have stone blocks everywhere. I think we'll need to modify the generation. But at least you can see the texture arrays are working. Okay, so let's change it to a 2D world. Okay, and generate and see. Right, so this is also just stone blocks everywhere. So what we'll do now is modify the height map algorithm, the way our blocks are generated, so that we are getting different values, the grass blocks also, and such cases. Because if you see the current 2D height map generation, right? Generate 2D height map, we either add the stone block or the air block. So let's modify this to actually add some different blocks also so that we can see the profound effect of our texturing system. So I modified this, and what I have here is pretty simple. So once we get our height value, right, we iterate over the z-axis. So if the height is less, if the current value is less than 3 of height, right, height minus 3, we can set it stone blocks. So everything up till height minus 3 would be stone blocks. Then from height minus 3 to height minus 1 would be dirt blocks. And if it's equal to height minus 1, that's like the top layer, that would be the grass blocks. And anything else, we'll put it as the air block. So now it's up to you how you want to populate your actual voxel data or the blocks array. And you can put all different kinds of blocks here. And depending upon these values, the values will be picked up in the engine by the material and the correct texture would be displayed. So let's compile this. Okay, one action with one process and it's done, right? So we play it, now we should see the grass blocks at top and then the dirt blocks and so on. Let's play it. And you see we have the grass blocks on top. And if we go to the side, you'll see what I meant by that. So we have the stone blocks, then a layer of dirt blocks, and finally the grass blocks. And that's pretty prevalent also. So okay, I think I broke my voxel editing, or it doesn't work in the negative chunks. So I'll take a look at that. As I mentioned in the last episode also, there are some issues with those implementations that I need to clean up. But you see here, right, as we go down, we see stone blocks, and this right here is a grass block, right? So the bottom face of the grass block is also a dirt block. So this is basically how you would add textures to your greedy meshing algorithm, and you can use the same approach for your naive meshing also. And even the texture atlas method would work, but the major benefit of using texture arrays is you can actually reduce the number of size because you just need 3 components. But as for texture atlases, you'll need 4 components, right? Because you will need a UV value for the actual texture to pick from the atlas, and the UV value for the scale of that texture. So you could say the index for a texture atlas is a 2-dimensional component, but for a texture array, you can just pass in the index as 1 dimension. So you save some performance there. And also there could be some artifacts in the boundaries of texture atlases, because once you sample at the boundaries, there could be some bleeding with the adjacent textures. One way to fix that is to have some padding in between them, but even those paddings can lead to artifacts. So by using texture arrays, you can avoid those artifacts. Okay. So I hope you like this implementation. It's pretty simple, and with just few changes, we are utilizing the engine and the material system to get as many textures as we want in our greedy meshing. So now we'll go over some suggestions and issues from GitHub, and I'll talk about the limitations with the current procedural mesh component. So now that we have our chunks textured, I really wanted to go over this chunk material suggestion that I got on our GitHub page. So what this would allow is to set multiple materials on the chunk, right? Right now we can only set one material. And why would we need multiple materials? So by having multiple materials, we can have some blocks shaded in a different way. Like you have water blocks and you need some vertex displacements in that, or some other kind of effects you need for particular blocks, like you have a light block that does some emission shader effects, right? So by having the ability to assign multiple materials, we can achieve that pretty simply. And this suggestion also talks about a very simple approach to achieve that. And thanks to Alrio, I don't know if I'm pronouncing that right, so pardon me for that. But what this implementation is suggesting is basically to utilize the create mesh section, right? So right now we are just creating one mesh section, and you can actually set different material per mesh section. Okay, so when creating the face, depending upon the block, we can change to which mesh section the current vertex would be added, right? And by using that, we can create different mesh sections. So we can have one mesh section for our texture array material. We can have a different mesh section for our water blocks, because water blocks would have a different material altogether, right? So using this, we'll be able to assign multiple materials, and we'll be able to create lots of interesting shader effects, and without modifying much of our actual mesh generation code, right? Because your mesh generation happens only once. It's just that you get different mesh sections out of that mesh generation rather than just one section. And each of those sections can have a different material. So I'll put a link down below to this suggestion also. Go through it if you want to implement it right now. We'll be implementing this when we actually start dealing with transparent textures and transparent blocks like water blocks. Okay. So this is one of the suggestions that I found pretty elegant, to be honest, because even I was considering to do something like this for our for the Unity implementation that I'm creating, which soon is going to be an open source library. So stay tuned for that. But I had a pretty different idea, like to create different meshes altogether. But so that would require multiple runs of the greedy meshing algorithm, which is not performant at all. But this solution right here, with just one run of the algorithm, we can get separate meshes. Okay. So really like this suggestion. And finally, coming to the second limitation that we have right now in our current system, that is that we are locked to the predefined vertex buffers or the channels that exist with the procedural mesh component, right? We have the color channel and 4 UV channels, and we can't even change their layouts or sizes. So ideally these channels should be enough, like to get most of your effects, right? You can repurpose the UV channels to pass some other data. They need not be just UV stuff. Okay, we can pass the texture index also in one of the UV channel, or we can pass the ambient occlusion, baked ambient occlusion values also. So that will keep it simple. But if you want full control over your mesh buffers, and that full control would allow for more optimizations also, right? You'll be able to optimize the buffer channels so that you can essentially minimize the amount of data that's passed to the GPU. And Unreal Engine actually allows you to do that using a concept called F vertex factory. And like the documentation on this isn't pretty great, but I found this great Medium article which talks about this. So what Vertex Factory would allow you to do is create a custom mesh component, right? And what this custom mesh component allows you to do is define your vertex buffers, your layouts and sizes for those buffers, and you will get complete control over that, and also how they're passed to the shaders. But all this control comes at a cost. Like these shaders, I don't think you can use the existing material system. You'll have to manually write the shaders for your custom mesh components. And as an example implementation, if you look at the static mesh component or the procedural mesh component, these components itself use the vertex factory to build themselves out. So I'll put a link down below to this vertex factory guide also. And it's a pretty complicated thing, right? I don't think I'll be covering this in this tutorial series because there's a lot of things that you need to define to get this working, as you'll be basically working with the vertex level or the pretty low graphic level thing here, right? You'll be directly interacting with vertex buffers, so it's pretty low, like your OpenGL or DirectX level thing you'll be doing. But at least those will be abstracted. You won't be writing DirectX buffers or OpenGL buffers, right? That abstraction would be there. But another thing that I found complicated is like we'll have to create our own factory shaders. I'm not sure if they could be used with the existing material system, or we'll have to type out our own shaders manually. But this is something that would help you to get rid of that limitation. So if you have exhausted all your available channels in the procedural mesh component and you still need to pass more data, this is the way going forward, right? And if you're really creating a production level engine, I would suggest look into this, and you'll be able to optimize your mesh data with full control. So that's all for this episode. We have completed what we sought out to do. We have implemented the textures for a greedy meshing, and you can mirror over the same implementation to naive meshing, but I don't think anybody would be using naive meshing, so I'm not focusing on implementing that anymore. Right. But if you want, you can, it's pretty simple to do that. And one thing we found out, there is a bug with our runtime code to the runtime editing of blocks. And if you have already have a solution, please do leave a pull request. I'll be happy to accept that. Or I'll fix it between the episodes and we can talk about that in the next episode. So that brings me what you would like to see next, right? We could start over the baked ambient occlusion effect, as I think that adds pretty nice details to our meshes. Or we can go over some other meshing algorithms. That is something that I'll need to research. Or we can advance our marching cube implementation also, right? We don't have runtime modification capabilities in that, nor do we have texture support. So any of these topics, leave them down below in the comments what you would like to see, and I'll be happy to create a tutorial on that. And if you have any other suggestions, feel free to leave them here or on the GitHub page, or if you have any contributions to make, feel free to do that. And like the video, share the video with the friends. It really helps the channel out, and subscribe for the upcoming content. Thank you.